Hi, welcome back to the breadboard. Been a while since I've done any projects, so I thought I would get going with a big one. As you can see from the screen right now, we have a pile of what looks like kind of junk, but they're all spares and things that I've had laying around for a long time from other projects. And what I intend to get to, which is on the right hand side, which is, some of you will already know, a Voron 3D printer. So the biggest thing with the Voron is obviously building the frame and keeping it square, and it provides a very strong and fast 3D printer that can print most materials, including ones that require a heated enclosure, etc. So why am I doing that? Well, it's been a long time since I've done a 3D printer. A few years ago I was looking at Vorons and thinking that might be nice to do and things like that, and really didn't do much with it. But in the past I have assembled at least half a dozen 3D printers and things with lots of upgrades and things, and presented them as videos on my channel, and I thought I would do something that would bring everything up to date with what's happening. But as per a lot of my other videos, I want to keep it as an educational experience, not just simply buy a kit or be provided with a kit and just assemble it. Some of my videos have been assembly, with the exception of later upgrades that I've done subsequent to the build. In this case, it is going to be fully sourced and or built from equipment that I already have in the lab or in the garage. So let's get into what I'm going to do. So what you can see here is a closer up view of some of the parts. I didn't put all of the parts I've got laying around because they just wouldn't fit within the camera view or on my table. So I kind of limited it to some of the key components. So at the back here you can see I've got this heated bed, 720 watts at 120 volts, that would act as my bed heater for this printer. I have some 1/4-inch aluminum plate which will act as the bed. Now, all of the printers I've had before, the plate has probably been at best 1/8 of an inch thick, just typical 3D printer that you buy off the shelf kind of thicknesses. The Vorons, one of the things they have is a very thick bed, bit of a heat mask to keep the bed temperatures even once they've heated up, etc. In this case I had a great big piece of this and was able to cut it down to pretty much perfectly the size I need for my Voron. In front of that you can see a bunch of ABS printed parts that I've already started printing in readiness for this. Some GT9 belt, I've got some GT3 behind there, I've got some small Gates 188mm pulleys that I would need for assembly. I've got an Octopus printer board with TMC 2209 drivers. I've got a CAN bus board for the tool head to save on a lot of wiring later on. It means you only have one wire, which is a bit like a USB cable but a bit more robust, going up to the print head from the control board to control everything. I'm not going to go into a lot of detail about that early on. I'll be waiting till we get closer to the build of the print head. I have a whole boatload of different size extrusions, and I happen to have almost enough 2020 extrusions that were kindly sent to me by RS Components a few years ago, and these are what I have left. I just have to get a few pieces of 2020 to make the vertical parts of the printer. I've decided that I'm going to make this a bit bigger. We'll go into that when we go into the initial frame design and build. Scrolling down a bit here, I've got some power supplies from previous projects and things left over, a solid state relay in this box, got some thermistors, I've got some BL Touch, although I may decide, because I think I have enough parts to do what is called a tap leveling system. Get into that as we go through. Fans, I've only put one stepper motor on the table, but I've got 6 of these. They're actually 0.9 degree steps, so that's like 400 steps per rotation as opposed to the typical 200, but they are powerful ones, so they should do until maybe I can get something better. A couple of different screen types. These are from old projects and where I've done other upgrades to other printers, so one of these should work for this project. I may have to design a front panel bezel for it, I have a 5-volt 10 amp power supply here. It's not quite the right design to go under the control panel, but there may be a way of fastening that there too. I've got a E3D V6 print head, but I also have, and I thought I had it here somewhere on the, oh, in here, it's amongst here. I also have a Revo print head, which I did some beta testing a couple of years ago, just before the Revos came out, and I have one which would be perfect for this build, which would be an improvement on this. So I'm going to probably go with this one, but I'm going to keep this one around anyway. You have to print different parts to mount the print head on the actual hot end, so I'll need to print parts for this one. Over the back here, a couple of Raspberry Pis. I've got a bit of the gantry printed and just clipped together. They're not screwed together or anything yet. Obviously with ABS you've got to be careful when you're printing to not get curling and things, because it would in some cases completely mess up your frame for the gantry and things like that, because you really need it to be perfectly square for things to work properly. I think buried hidden behind here is part of the Z-axis assembly, which was where the motors will drive. One thing I did buy, I managed to on Black Friday sales, was a gear set, and this will allow me to do the Clockwork 2 extruder. I didn't have enough of one color of ABS. I'm trying to minimize any cost by using materials and equipment that I already have. So these are printed in 2 different colors, but as you can see back here, predominantly I'm printing in red and black, but I've got a couple of pieces that are in white as well. Shouldn't detract from anything. I think the one few parts that I have which may not have enough of are the panels for the sides, but you know, they have acrylic panels for the main Voron build specified, but it wouldn't matter if you used plywood or something. It's there to contain the heat, and having a clear panel would obviously mean you could see in from the sides. Going on from some of the parts that I already have, I also have some bigger sheets of aluminum and things in the garage, and some other things like linear rails that I haven't put on the bench that I already have. The reason I decided I want to build my Voron taller is because I actually have some linear rails that are longer than the standard, but they're still the MGN 9H type, which is called for the Z-axis, one in each corner. So there's actually 4 Z-axis motors, etc., or Z for those in Europe. Let's go to tools that are required. Okay, so here is a downward shot of my bench. I've put a few tools out which would be typically used when you're constructing a Voron printer, any 3D printer really. So what we have up here is some Kapton tape if you want to put some insulating material on something that's going to be getting hot. I've got some 3M HDP tape. I got more, but this is just a smaller roll to put on the bench. Some various set squares. The first one is the machinist one I've had since I was about 16 years old. It's been a bit beaten about, but the main 90 degree on the inside is still good. There's a little bit of a divot here where I think somewhere over the last 30 years it got used as a hammer. Not a good idea if you want to keep some quality tools, but it is what it is. This is a standard kind of T-square that a carpenter would use. It's not terribly expensive from the likes of your Home Depot's hardware store. So, you know, different stores, different names, but they all seem to sell this kind of product. This one is more of a machinist tool as well, but it is adjustable. You can do 45s and 90s, and you can slide the ruler in and out and things like that. Any of these 3, providing they're giving you a true 90-degree angle, would be good for verifying some of the assembly requirements for the frame, certainly, which is critical to get certain things aligned, and we'll talk about that when we are building the frame. We have I've just put the tap holder here, but you will need to tap some M3 and M5 and possibly other thread sizes into various pieces of plastic or metal, especially the frame, so that you can screw it together. Now, a lot of the plastic parts we use heat set inserts, so you also need a heat set insert tool. Now what I have here, which is not necessarily ideal for heat set inserts is a standard soldering iron. What I have here is a sharp tipped iron, and it's round. All right, that would work okay, and it would go in slightly, but at least it would give even pressure all the way around the heat set insert so it doesn't twist and go in crooked. That's my heavy duty iron that I normally use, and I normally have this tip in it. As you can see, it's got a bit of a wedge on it, so if you try to use this, and I did test a couple of pieces, it will want to drive them in crooked as the heatset insert tries to angle itself to even the pressure all the way around. So that's not ideal. At the end of the day, if that's all you have, then you just need to work with it. And I found if you screw in a long M3 screw and then use this to heat the inset next to the screw, you can hold the screw keeping the inset straight, and then it will just gently sink into the plastic. So that's one way of working around it. As I said, not ideal, but if it's all you have, then it will work. So some other things that you will probably need: heat shrink tubing. Most of what you're going to need is going to be the really thin stuff, where you need to join wires and you need to put some insulation on them to keep them protected. I've got a few needle files here. If you don't have needle files, then regular files would do. Not all extrusions and things come out perfect, and you may need to just trim burrs off the side. Same with the plastic. When you 3D print ABS or any other plastic, often you'll get a little bit of an elephant's foot or something like that. And if you're into 3D printing, you'll know exactly what I'm talking about. If you're not, it's just where the edges that were on the build plate or elsewhere have bulged out of what you're trying to print slightly, and they just need to be filed off or cut off with a sharp knife. Wire strippers are almost a must. Now these, I've been lucky. I'm an electronics engineer by trade. I've had these since I was about 16, 17 years old. Still going strong, and they do a great job of stripping smaller wires. I also have a really big pair for doing mains cable and things like that. They're not cheap, but they do a really, really good job. Now you can get lots of other strippers that are just little circles that would bite around the wire, and then you just pull the insulation off. They also work perfectly well. Just I happen to have the nice tools because I've been in the trade of that kind of thing pretty much my whole life. Scissors for cutting tape and other things. Hex screwdrivers. Now I have regular hex, the kind that you would buy from a hardware store or something like that. They don't have to be terribly expensive. The ball end ones, if you're trying to tighten things up tight, and have a tendency to round off the hex nuts if you're not careful, but these would still do. There's nothing that you really have to ram down on when we're building a 3D printer, so these would do nicely. But for a little more finesse, having hex drivers that have got preset tips and they're on handles are really good for smaller pieces, or driving in M3 nuts, M3 screws. These would still be perfect kind of job. So if you happen to have something like that, that's great. I actually acquired these when I was in my early or middle 20s, when I was taking my kids out for remote control car races and things like that. It was part of the toolkit I had from that. Now one big thing that I got a few years ago was this iFixit kit, which actually has everything in it that you would need. All the different types of screws, hex, flathead, crosshead, a few nut spinners, tweezers, levers, right? Everything you would need. I showed you the nut spinners and things, which are great, but this would also work where you don't have to have deep reaching sockets that you have to go through. So this would probably do for 90% of what you're assembling. Now in my case, because of some of my extrusions, I will be needing to go up to, I think, M6 size, which this really won't give me enough torque for that when I'm assembling the frame, but nice thing to have. This one is because I do a lot of repairs and messing around with computers and tablets and things like that, so this is an ideal kind of toolkit for that thing. One of the other things that you might find useful is a small impact driver. This one isn't actually an impact driver, it's just a driver, but it works perfectly well. I've just got it, right? Doesn't go terribly fast, which is great. And it allows you to screw in some of those longer screws that really get your wrists sore when you've been screwing things in for a while. So that just makes it, that's a quality of life tool, if you, for want of a better word. The bigger screwdrivers or drills, like this kind, you can use them. I wouldn't use them for putting the screws in. One of the things that I have found is that some of the holes, when they're obviously they're 3D printed, they're not perfectly round. So using, this is a drill which is just under size for a 3mm hole, for an M3 screw clearance hole. So running this through some of the 3D prints is just enough to clear out any little bits of filament that have blocking the hole and things like that. You don't need to go fast, but it does the job if you need it. But I wouldn't use something like this for putting in screws, especially the smaller ones, because you're just going to strip them right out. And that includes ones that are going into the heat set inserts, right? Because they're just in plastic, they will strip. So avoid this for that kind of thing, but certainly it's okay for doing some clearance holes and things like that. Also, you can put a tap into one of these. I would remember to turn the torque down so you're not going to strip or break the tap, because they are quite brittle because they're hardened. But you can drive the tap in once you get a little more proficient, and just reversing the direction to pull it out and, you know, going back in and out is an easy way. When you're doing a lot of tapping on the end of extrusions, your arms and wrists can get quite sore. So tip for that, using one of these. I mean, the tap wrench definitely does the job, just a little slower. One other thing I have, which again, not bought, but, well, the case was bought several years ago, is a big selection of screws and things like that. So these were gifted to me for projects that I did quite a few years ago with RS Components out of Europe. So I've got a whole bunch of different M3s, M4s, M5s, and M6 nuts of either cap head, standard sockets, or flats. So this was an extensive start for me getting all the screws that are required for the build. Without this, it would have cost me a lot of money. And now, regarding buying screws and things, let's get that out of the way. I was looking on Amazon for screws. They're horrendously expensive for getting just a dozen screws, or, you know, even 100. You're paying a lot of money. I went to a local industrial hardware store, and I got for, it was 100 or 200 M3 screws for $7. That's Canadian, not US. That same thing on Amazon or somewhere would have cost me $30 or $40. So not everything is cheaper on Amazon. In fact, a lot of things are way more expensive. Okay, let's just wrap up a few things. I'm going to show you some crimpers that I have. The Allen keys and things that you need, metric, not imperial. If you start using imperial ones, some of them will work until you start trying to tighten up the screw, and then it's going to slip and start rounding things off and making a mess. So get yourself some metric ones. You don't need a huge, like, massive kit. I mean, even this is overkill, because these big ones are never going to get used. All right, just a small set with these main sizes, M5, M6. That's all you need to go up to. Nothing is any bigger than that. So you don't need to spend a lot of money on those. And even smaller Allen key sets. This is just one I've had since I was about 16. Again, RS Components. I used to live in the UK back in the day when a lot of things from RS Components was actually made in England or in mainland Europe. You can see a few of the keys have been changed over time, but that's all you need. Something like this. This is a metric set up to 7mm. More than enough. So, crimping. When you start crimping a lot of the connectors that you are going to be using for the build, you're going to be having things like this. Okay, This is just a jumper wire, but this is the kind of crimps you're talking about. And crimpers require specific crimping tools to work. I've seen a lot of people use just a pair of pliers or tweezers to crimp the connection, and you'll get away with that most of the time, but you have to be really careful. Now, you know, the crimps come on little strips like this. You get the socket, these are just the pins, but you get the sockets as well. And you can see down here it's very small for crimping. This crimper goes smaller, could do the job. And then I have one that's in the middle of the range, which probably would do the job for these end ones. All right, they're different styles. This one I'm lucky to have, well, I'm not lucky to have, but this is a iWis, which I got from AliExpress a few years ago, and I've never needed to use this very end crimp connection. But when I got the tool head PCB with the CAN bus, they use some extremely tiny crimps that there's no, I'd even have to use a magnifying glass with this tool to be able to get them in there and done properly. But these type of crimpers, this one came from AliExpress. I think it was like $50–60 years ago, and I looked and they're still about the same price. It's ratcheting, so you can get your tool, your crimp in there and then relax a little bit while it holds it, and then get the wire in and then crimp it down, which is really nice. Now, there are cheaper options available, and one of the ones that's actually recommended, and I think I mentioned it in the bill of materials, is this one. It's a PA09. This will also go all the way down to the tiniest crimp that I just mentioned. They're still quality crimps. It's just a little more tedious because it is not ratcheting. So if you're doing it and you just relax your hand a little bit, it's going to flop out. And this big one is if you're doing mains kind of wiring. These are all just different boxes with different types of crimps in them that require those crimping things. I've been doing electronics all my life since I was 16, so a long time. Nearly 50 years. This is more for automotive and mains level crimps and stuff like that. So this is the kind of thing you would put on the back of the mains power coming in. It would loop in and you would have spade terminals going onto that, and then you would probably put some heat shrink tubing over the top of the whole thing just to keep it from fingers touching. But yeah, big loops, smaller loops, etc. You got to make sure that you use the right color. So you can see these are color coded, and where's my crimp tool gone? It's underneath. This is actually color coded for the right one. So you got red, blue, and yellow. So you use the right color crimp. So the colors of these are usually referring to the wire size that's going to go in the end, not anything else. It's not about voltage or anything like that. And use the right color for the right crimp. Anyway, just thought I'd mention that at the end because it's important. And believe me, you do want to have at least this kind of crimp if you can. Right? Obviously, if it's not in your budget and you're adept at doing it with a pair of really small pliers, probably tweezers, then okay, but you may not get the most reliable joints. So definitely recommend, if you're going to build it, if you're spending that much money getting all the parts together anyway, then it's not a huge increment to get yourself at least this kind of tool. This kind of tool, especially for these tiny crimps, if you go to DigiKey for their equivalent from not 3M, might be 3M, anyway, it was about $800. This is about $60. Now I'm sure the one from DigiKey has got a whole boatload of other features and things like that, which would be nice in an industrial environment. For what we're doing for just building a 3D printer, this one is probably going to be more than adequate. So shop around. I think that's everything. So I'm going to wrap this up because it's getting to half an hour and I didn't want to be too long with it. So the next thing to look at is actually what is a Voron.